Okay, part two for our exponential functions today, we're going to talk about a little bit about exponential growth. Exponential growth, obviously taking some sort of amount and having it increase by a certain rate over a given amount of time. Now, if I zoom in a little bit here, looking at my exponential growth function, my formula, if you will, we got basically three things that we need to know and we need to plug in. Number one, we need to know our initial amount. What are we starting with? Okay, that is going to go in for A in the front of the parentheses. The second thing we need to know is how fast is this thing increasing? What's the rate? Now, the thing that gets tricky about rate is we do need to convert some percentages into decimals, and I'll show you guys how to do that in a little bit. Last thing we need to know for our exponent, we need to put in a amount of time. So like how many years or months or whatever it is, how long are we waiting? How much time is passing? So let's look at two examples. Okay. The first one, we have a painting. It's worth $9,000 and it's getting more and more valuable as time goes on. The value is actually increasing 7% each year. We want to know in 15 years, like if we wanted to resell this in 15 years, how much is it going to be worth? Okay. So first thing I notice is the 9,000. That is our initial amount. That's what we're going to put first. Again, like I mentioned in part one, whatever you're starting with in the problem, that's kind of what you should be starting with in the formula or the equation here. Now here's where things get a little tricky. This is usually the part that a lot of people mess up. The 7% is going to go inside the parentheses in the blank. However, we need to convert it to a decimal. We need to take 7%. We need to think about moving the decimal point over. So if there's a decimal point right there, we need to move it over once, twice to the left. We're going to fill in the 0 as we go. So 7% as a decimal would be 0.07, and that is what goes in the parentheses. Okay, if you just put the 7 in there, what's going to happen is you are going to get some very, very, very large numbers, which is usually a red flag that you did something wrong. Okay. The last thing we're going to do, our time, our 15 years, is going to go up into the exponent. Now from here, all we need to do, I'm sure you already kind of guessed it, we're going to grab Desmos. And we're just going to type this in. So we got 9,000, parenthesis, 1 plus 0.07. I'm going to hit my exponent button, which is that A to the little b. It's going to move my cursor up. And I'm going to put in my 15. And it's looking like in 15 years, split my screen like this. In 15 years, this painting is going to be worth, I'm going to count 2 decimal places because we are talking about money, about $24,831.28. Okay, so if you have a $9,000 painting, 15 years from now, you can sell that for almost 25 grand. Okay. Let's look at example number 2, kind of the same idea, but this time we're talking about the population. In 2000, there were 6.08 billion people in the world. Our population is increasing about 1.26 each year, and we want to figure out what was the approximate population in 2012. Okay, so kind of using this information back in 2012, how many people were there. So first thing I need to do, let's take that 6.08, let's put that in our initial value spot, in our first blank in our equation. The second blank, we need to take our rate, the 1.26. Let's change that to a decimal. Again, I'm thinking about taking this decimal point and moving it over once, twice to the left, filling in that 0. So as a decimal, 1.26% is 0.0126. The last thing we need to fill in is the time. Now we have to do a little bit of thinking here. It doesn't give us a time to plug in, but from 2000 to 2012, that's 12 years that's passed, right? If you count the years. So our exponent up there is going to be 12. Okay, just like we did with the first one, let's take this formula. Let's just type it in exactly how it looks. So we got 6.08, parenthesis 1 plus 0.0126. Let's move that cursor up, hit that exponent button to the 12th power. Okay, let's cut this off at 2 decimal places. So 7.06, the 5 is big enough to bump up to 6. So this is going to go up to 7.07 billion people. Okay, let me zoom out here so you can kind of see all of that. So that is exponential growth, taking some sort of value, whether it's money, whether it's a population, and having it grow over a certain rate. Obviously, you can see what we started with is smaller than what we ended with because our amount was increasing for exponential growth.